antibody-mediated response, or the Th2 division, okay? And you go back and forth. You got everything right here. Go back there and write antibody-mediated up there. That's the division, the name of this division. So write in antibody-mediated. And we'll help you get your notes together, okay?
Where did you
On the page 3. Antibody-mediated number 1. We have number 1 and 2. Antibody-mediated and cell-mediated, okay? Well, this is antibody. This is that. And what are the cells that are involved here? The cells, these are B cells. So right here, put B cell. They're the ones activated. They're activated directly. Remember I said directly by whatever they've been programmed to deal with from antigen they've been programmed? Directly. So you said have a direct activation there. So if you want to write direct there, you can. Just to remind you that when they come into contact with it, they will know it. Now, what is it that's activated? Well, it's whatever they are set up to be programmed to deal with, these target antigens. Oh, well, now what are they? Let's go back to this page. And we see number A right here, primary target antigens. Okay? That's your answer, you see. So it's all right here on this page. And what does it say? Anything that's free in the body fluid. Like what? Microbes. So put in here microbes. Parasites. Proteins. But parasites, by the way, can be amoebas like cells, or it can be a helminth. A helminth is a worm, like a pinworm or something like that. That's what a lot of the parasites are. So that's why I didn't spell them out, but you can go over and look at all the details are here. Now these are things that are as I've indicated here, are free in the body fluids. They're out in the open. Now there's different ways when you go hunting. There's different ways, like say rabbit hunting. And whatever you got your dogs and whatever, but they jump a rabbit, and you might get a shot at it, and might not if it's out in the open. If it's out there running free, somebody says, "Hey, he's coming your way," or whatever, you get a shot to shoot him. Some people go, "Ooh, well, all right, rabbit." Grew up with that. Now, if a rabbit went into a hole in the ground, where they have some nest, they went in the hole in the ground, I can't shoot at that rabbit anymore. He's not free, he's not out in the open where I can do it. And that's the same way here. As long as these target antigens are out in the open, in the body fluids, these proteins are floating around, or parasites are out in the open in the body fluids or in the bloodstream, or there's microbes out swarming around, you get a shot at them. The antibodies can deal with them here. These are B cells. They can deal with that. But if these things ever go into another cell or hide somewhere, you can't send some other tissue, antibodies can't get them. It has to be, they have to have a clear shot at them to do this. Basically, as I said, there are some exceptions. So that's why I said they're free in the body fluids. Okay. Because we're going to see there's a difference there. What if they are? What if they go into a hole in the ground? Well, you might have a little terrier dog and mixed in with your rabbit dogs, and they're going in and dig them up. See? So you have another way to do that. Okay, well, let's go ahead and then look here. Then once they get activated, we have the next step. If you look at your page, and be sure to read this page 3 there. It says there's differentiation. Then once it gets activated, these B cells differentiate. And what are the cells? Let's look over there and see what are those cells that they differentiate into. It's number 1B. What does it say? Differentiation. What is it? When activated, what do they turn into? Plasma cells and memory cells. So put a memory cell right here. And put a plasma cell right here. Because the plasma cells are going to be the ones working. The memory cells are there for memory. In other words, for the next infection. They may live for years, hanging around, waiting for that next infection. If it ever comes through, they're ready. They'll turn into plasma cells in a hurry, and they'll go. But right now, plasma cell is the one that's going to do the doing. Now, what's the next thing we have here? Proliferation. Then they begin to proliferate. They begin to increase their numbers, the plasma cells. You see, I put a bunch of them right here. Plasma cells. Now, what do? They make antibodies. There's an antigen. Here's a B cell. It turns into a plasma cell. The artist got it wrong. The plasma cells wind up way bigger than the B cell, the original cell. The B cell differentiates into a memory cell and a plasma cell. There's a plasma cell. It gets real big, way bigger than they're showing. And it makes sort of Y-shaped antibodies. Antibodies tend to be Y-shaped. And turns them loose in the jillions. Sometimes they say they can make them 2,000 a minute, and I've heard 2,000 a second. I hardly know what to believe. But so many that it's just incredible. You turn them loose into the body fluids and they can't miss. Now they bounce off everything they're not made for. But if they're made for like this antigen that they're programmed for, it took them a while to get programmed. It took them a while to get ready, but once they did, they turned their antibodies loose, and they started sticking to this thing until they covered it up. They formed what's called an antigen-antibody complex. Now that's in your outline, so it'll be repeated, but they form it up and they get it completely where now it can't do any harm. It's kind of like tying up a burglar or something. They can't do it anymore. You call the police, come get them, but they're all knocked out or tied up, and so that's what winds up happening. So, you can see these Y-shaped little antibodies that I made remind you that's what happens, and they descend out here on these target antigens, whichever one it might be. Well, what do they do to them? What are the actions they do? Well, there's a choice, not always the same thing. Some of them do one thing, by the way, antibodies are called Ig. So you might write down in that swarm of little Y's there, you might write Igs down there, because that's what they are. And there's different actions here. Let's see over here. We have at the very bottom of this page, we have down here, we said actions. Actions. They neutralize and phagocytize. Some types of Igs cover the antigens and toxic sites and neutralize them and hold them, or for maybe a macrophage to come along and eat them up. Then they just swarm them and tie them up and wait for the macrophage. So they neutralize them by swarming them and forming this complex, and then the macrophages come along and finish the job. So right there, in there, neutralize and phagocytize. Well, what's the next thing they do? Lyse. What does that mean? To tear open, tear up. Some cause the lysis of microbes in single parasites. They actually can cut them open, so put lyse down there. Or if they can't, they can get an eosinophil. Sometimes these worms are so big, as you see down there, they need an eosinophil, a big blood cell, to come along and line up around these big long helmets up and down the length of them and secrete some stuff that can cut a hole in them. But it's lysis. It'll kill them. Could be an amoeba. You land on them, Maybe they can, through some other effects, they can cut holes in them, but the whole point is they lyse them. The third thing is inflammation. These cells, they can degranulate mast cells and produce inflammation. We've talked about that. Mast cells have heparin in them and also have an inflammatory agent in them. So we're getting inflammation to recruit inflammation to help us in this battle. Because inflammation and all that helps stir up our own immune system. It stirs us up, makes them fight harder. So does fever. So those are the actions you put in there. Neutralize and phagocyze, lyse, and inflammation. Okay? So you can always go back here and get all the details. Now what I didn't put up here was this cell right here. This cell is a Th2 cell. So write that in where that cell is. Well, this is called a Th2. They name these according to this cell right here. H means helper. This is a helper cell. It's all right here. Page 3. What do we need the helper for? The helper cells secretes this stuff right here. See these things here? It speeds up proliferation. Instead of running 100 miles an hour, it runs 1,000 miles an hour. So we proliferate these plasma cells at a much, much higher rate because of what the helper cell releases. What does it release? What is that stuff it's releasing right here? Cytokines. So write that maybe in there to remind you of what that stuff is. You put it right in there. Cytokines. Kinetic refers to some action, work. Something that's working, doing something, accomplishing something. Cyto means a cell. These are things that are secreted to get cells to do something. In this case, proliferate. They're different kind of cytokines. We'll talk a little bit more about it. They do different things. Okay, now, where do we get this helper cell? It's a T cell. Well, it has to be, it comes from the T cell line. Well, what about that? It comes from over here. Put right here, put where this cell, put a T cell on there. Say T cell. Now, what would activate this T cell? The same thing, if it's programmed, it has to be programmed. The same target antigens. This cell right here, you can put it down as an APC. Put down APC. That's an antigen presenting cell. It's typically a dendritic cell, some kind of a big macrophage. And it will come along and eat some of this stuff right here and put it out on the surface of its cell membrane along with its own self-antigens and poke it out there like you see in a little drawing here and run around until it finds some T cells that are programmed to deal with that thing. And if they are, then it'll activate this T cell. Now this is the attack side, you see. The T cell side is the assisting side. It's just going to assist. Well, we're going to get to the T cell reaction later. It's on the other side of your outline. They're going to do everything. But it turns out that the B cell response needs T cells to help them. T cells don't need any help. But once we get a T cell activated by the same target antigen that this B cell is activated, now they're working together. So this T cell will differentiate too. What does it differentiate into? A Th2 cell, that helper cell. A TR cell. TR. This is a regulatory cell. It's all right here. You can go back to the page and see what it says. TH, TR, whatever. Notice what that TR is doing. See those little beads I've drawn there? it must be releasing something, probably some kind of cytokine or something, and what it does is the TR refers to regulatory. It helps regulate things. Well, we'll get to that. We'll get to that next time. But we haven't gotten, it's not as important, but it stores it back. It's just there handy, ready to deal with this, and it may speed this up or it may slow it down, depending on the need. And it's a regulatory cell. Then it'll do this one is a TEM cell. TEM cell. What kind of cell do you think a TEM cell is? Memory cell. It's a memory cell that's a T cell. Why? Well, in case this thing, this antigen comes back through town, we're ready to go. We got the B cells can act and the T cells can we got a memory cell here, it's ready. We don't have to waste any time here. We don't have to wait 2 weeks or 10 days. It's ready by noon. It's ready by noon. You walking around with people, you've already had whatever they had. You're walking around, it doesn't bother you at all. Well, it's in there. They're fighting you, but you got memory cells that are just tearing them up. Memory cells that created this situation and tear them up. So this is what you fill that out. I think you got everything there. Once you need, and what we'll do is we'll talk through this. The next time we'll go back over this. So you got the big picture here. We hadn't even talked about the killers. I like to get the killers. Blood good.
What did you say is the TR?
It's a regulatory cell. It tends to regulate, it tends to modulate the system. It's kind of speeds up and slow it down.
What's that coming from it?
Coming from the T cell.
From the TR cell?
It's cytokine, some kind of cytokine. Yeah. Now, turns out that that's why I said the T cells are real. They got a lot of roles to play. It takes them a while. They got to go to the thymus gland. They got to get some training there. And so we got all kinds of them. We'll see them over here. Now there's one cell we don't have here. You might just make a note of it mentally, or you could write it down, but I don't know. They don't. That's a TC cell. A TC cell is a killer cell. This is not the killer cell of the body. See, this is antibody mediated. You've got the killer cells over here. On the other side here, see. Now that's where we get the T killer cells in. They're called cytogenic, where they let's see if I've even got it on. I'm not sure I even put that on. But the TCs are on it, and they actually tear things up. Let's look at these on page 3. You'll see antibodies are called immunoglobulins. Globulin means a big wadded up protein. It's part of the immune system, an immunoglobulin, a globular type protein. It works. That's why they're called Igs. That's why antibodies are called Igs, for immunoglobulin. Because they're different kinds. IgCs, IgTs, IgEs, different ones. I'm not going to go into that. Maybe we'll do that for micro. I'm not going to do it. It's not necessary for me to go through that. They're made by the plasma cells. They're custom made for their particular end. They're released in the blood and body fluids, tears and saliva, they're in mother's milk, everywhere. Some can cross the placenta and immunize the fetus, get across, they're small enough, you get across there, get in the baby's body, so while the mom is pregnant, the baby didn't get sick. Pretty rare. Others are found in mother's milk. Hey, so the baby's immunized in mama because the Igs go across the placenta, and then when the baby's born, now out here exposed to everything, gets mother's milk in exactly the right place. Most infections, take place right here. Well, right there is where mama's giving that baby the milk with all these Igs and everything. And it contains critical factors for development of the baby's, so it's necessary for the immune system too. There's some stuff in mother's milk that's like marijuana, by the way. Just kind of a funny little, just I think I can't escape it every time I think so. I see it show up again. So anyway, we've got things in our body that fit all that too. Fun, we're made for it, but anyway. So those are just a few little tidbits, that I wanted to kind of make sure you kind of got the idea of before we left. And you can read all that, it's all on there, on page 3. You go back over it. Next time what we'll do is we'll do the same thing. We'll talk about the T cells, the Th1. Okay? Let's do it. Now go ahead and look at whatever you want to and whatever you want.